In the initial weeks, our focus was on building the right thing, right? Identifying the correct requirements, communicating with the clients to get the right requirements and so on. Once we hone in on what is the right thing to build, now our focus shifts to building it right, making sure that we have done it properly. So, we have decided the broad architecture of our system, started the development. Now, one important thing to do is to effectively test our system so that we are actually building the modules correctly. Why is testing important? Even seemingly simple errors like integer overflow can cause entire systems to crash. There is a lot of data on how much effort and time and money has been lost because of simple bugs in software systems. For example, airport system failures or spacecraft crash. Many of these you can find in the extra resources associated with this video. So, here is a reflection spot. Have you tested a program? What are the basic activities that you did to check if your program is working correctly? Take a moment, think about the programs that you have submitted in past assignments and think about how you did the testing.
Okay, so now let's reflect on the basic activities you did while you tested a program, right? So usually what do? Let's say we have a program, we provide some inputs, we check the output and we see if the output matches the expectation or the required output. If not, we locate where the error is, we identify the error and we fix the error and then we test again, right? And we saw some of these steps in our debugging video, right? And if you notice, the first step which we do is we provide a set of inputs. And this is known as a test case. So a test case contains three things. It's a triplet, right? It contains I, which is the data input to the programming. And then it contains the state of the program, S, right, at which the data is to be input. For example, in the case of our online seller portal, so after login, let's say on the catalog page, the user clicks an add item to the catalog and fills all necessary details, and then let's say clicks on add item, right? Now we are trying to test the functionality of this add item. So this is the current state in which the program is in. And the third parameter is R, which is the result expected to be produced by the program or the system, right? So in our case, we expect the catalog page to be updated with the new item when I click on add item. Now, the set of all the test cases which have been designed to test a given program is known as a test suite. So let's look at a summary of what all activities are involved in testing. So first, we have the test suite design. That is, we come up with appropriate test cases. And how do we do that? We will look at that soon. And then we run test cases and check results, right? So each test case is run and the results are compared with the expected results. And if there is a mismatch between the expected results and the seen results, that indicates a failure. And these failures are noted down later, maybe for debugging. And this is usually done by a tester and reported to the concerned developer. And many a times the tester and the developer are the same, right? So the developer who writes the program is the one who tests it as well. Then we have to locate the error, right? So each test case which fails, it has to be checked by the developer to look out for where the error is, right? And finally, we correct the error, we change the code, and then we test it again with the test cases.
So, the first step is to design test cases. Why do we need to design test cases? Why not just randomly test for a large number of random values? In that way, perhaps we might save a lot of effort. So, take a moment and think, why do we need to design test cases or choose test cases carefully? So, it is necessary to design test cases for many reasons. One of them is, if we test for a large collection of randomly selected values or test cases, it does not guarantee that you have caught most of the errors. Why not? Let us consider this simple program which calculates the minimum of two values. Okay, we are comparing two values x and y. If x is less than y, then the minimum should be returned as x, else the minimum should be returned as y. This is the correct program. Now, let us say there is an error in the program, and in the else statement again it says the minimum is equal to x. Now, by simple examination you can see that there is a flaw in it, but suppose we were to test with randomly selected values, where x is always less than y. For example, 1 and 2 or 3 and 4 or 1000 and 10,000 and so on. If the random set contains only such values, it will not be able to detect this error. So, the error will be found only when a value comes in actual operation which does not, in which y is actually greater than x or y is less than x, right. So, it is important to design test cases carefully. So, having talked about random values, we may think, why do not we exhaustively test all the values? Now, as you could imagine, the domain of all input values in a software system is very large. We cannot test for all possible values again. So, it is necessary to design a minimal test suite where each test case has a particular function. It is designed to catch a certain type of error. Now that we have understood that it is essential to choose the right type of test cases or design the right type of test cases, how do we go about doing that? One way is to analyze the input output behavior only, right. We do not look at the code at all. For example, in the previous program we just keep putting values where each pair has a different relationship with each other. So, we know what the functionality is. The functionality is supposed to calculate the minimum. So, we provide two types of test cases where the first value is the minimum in one pair, the second value is the minimum in the second pair, and maybe a third pair where both the values are equal to see what happens. Okay, this is known as black box testing. The program is like a black box and we are not looking at what is inside the program, how the code works and so on. We are simply giving inputs, we know what the program is supposed to do, we are simply giving inputs, we know what the expected output is, and we are seeing whether the expected output is given by the program or not. This is also known as functional testing. So, we will look at black box testing techniques in the upcoming videos. Now that we have seen black box, obviously there is another way, which is the white box, right. So, the white box testing is to analyze the structure of the program. The idea is that the program is like a white box, it is transparent, you can look into it. So, this is also known as structural testing. How do we do that? Again, going back to the previous example where we are trying to calculate the minimum of two numbers x and y, we look at the code and we analyze the code and design test cases such that every path of the code is taken. So, we will design a test case such that for one input the if branch of the code is taken, and then for another input the else branch of the code should be taken, and then we see what happens when we actually run the code. So, essentially what we are doing here is we are checking if all the paths of the program, all the different paths that the program can take from its beginning to the end, whether they are all covered by the test cases. This idea is also called test coverage, where you are ensuring that your test suite covers all the possible paths that the program can take. Again, we will be looking at white box testing later in this week.
Now there are different levels of testing as well. So to start off, you do unit testing, where the individual functions or units of a program are tested. And once these individual functions or units are tested, then they are incrementally integrated and tested after each step of integration. And this is known as integration testing. Right? And now after we have integrated all the units together, the fully integrated system is tested. Right? And this is known as system testing. And there are different types of system testing. One is alpha testing, where the test team within the organization does the full integrated system testing. Or another type of system testing is beta testing, where the entire system is given to a select group of customers. Then finally, we have what is known as acceptance testing, where we give the system to the customer and the customer sees if the system satisfies the requirements or the user stories which were communicated to the team at the start, right? And they determine whether to accept the delivery of the software or not. And apart from these, there are other types of testing like performance testing, which is used to meet the non-functional requirements of the system. So we will look at these different levels of testing also this week.